Welcome back to our lesson. Today we are going to look at chapter Rate of Reaction. In this chapter, it is very important for you to understand the factors that affect the ROR, which are known as rate of reaction, and how the collision theory relate to the factors. And you also need to memorize which are the experiments that you need to do to compare the factors. So make sure to stay focused in this lesson. And without wasting our time, let's get into our lesson. In general, chemical reaction is the interaction between chemicals to form a new substances. Chemical reaction takes place at different rates. Some take place at high rate while others occur at low rate. Reactions that occur fast have a high rate of reaction. On the other hand, reactions that occur slowly have a low rate of reaction. Now, let's take a look at the formula used in this chapter. Rate of reaction is equal to change in quantity of reactant or product over time taken for the change to occur. These formulas are related to the meaning of rate of reaction, which are defined as a change in quantity of reactant or product during a reaction per time. The common unit for the rate of reaction is gram per second, centimeter cube per second, and mole per dm cube per second. Now, it's time to look at the factors that affect the rate of reaction and relate it to the collision theory. The collision theory states that a reaction between two particles can only take place if the reacting particles collide with each other. And the factors that affect the rate of reactions are size of solid reactant, concentration of reactant, temperature of reaction, and use of catalyst. Pressure is also one of the factors, but it will not be asked in the exam. So let's focus on these four factors only. Let's talk about the first factor, which is size of solid reactant. For this factor, we usually take this experiment as a reference where we use marble chips calcium carbonate and a powder calcium carbonate and add a hydrochloric acid into both of it to liberate carbon dioxide gas. The rate of reaction for experiment using a powder of calcium carbonate is higher than experiment using a marble chip of calcium carbonate. This is because the smaller the size, the bigger the total of surface area that are exposed to collision. Thus, the frequency of collision between reacting particles will increase and the frequency of effective collision will increase too. And that is why the rate of reaction for the smaller size of reactant is higher. For the second factor is concentration of reactant. For this factor, we use experiment between sodium thiosulfate and sulfuric acid as a reference. We use a high and low concentration of sodium thiosulfate to compare the rate of reaction between these two experiments. An experiment that have a higher concentration of sodium thiosulfate have the higher number of reacting particles per unit volume. Thus, the frequency of collision between reacting particles will increase and the frequency of effective collision will increase too. In conclusion, the rate of reaction will increase higher for the high concentration of sodium thiosulfate compared to the low concentration. Moving on to the third factor, which is the temperature of reaction. For this experiment, we can use the previous experiment in concentration factor, where we use a reaction between sodium thiosulfate and sulfuric acid, but this time, the manipulating variable is the temperature of sodium thiosulfate. You can compare the rate of reaction between a high temperature and low temperature of sodium thiosulfate and observe the time taken for X mark to disappear. And using the collision theory, the higher the temperature of a reaction, the higher the kinetic energy of a reacting particle. Thus, the frequency of collision between reacting particles will increase and the frequency of effective collision will increase too. In conclusion, the rate of reaction increased for a higher temperature of sodium thiosulfate compared to the low temperature of sodium thiosulfate. Last but not least, for the last factor in this lesson is the use of catalyst. Before I explain how catalysts are related to the collision theory, I am going to explain what is a catalyst. Catalyst is a chemical that can change or alter the rate of chemical reaction. Catalyst does not change the amount of products. After the reaction completes, catalyst does not change chemically but may change physically, such as solid catalyst might be crushed. In this experiment between zinc and sulfuric acid, we use copper 2 sulfate solution as a catalyst. The presence of catalyst in this experiment increased the rate of chemical reaction. This is because catalyst provides an alternative path which lowers activation energy. And based on collision theory, catalysts increase the frequency of effective collision. Thus, catalysts increase the rate of reaction. And that is all the explanation about 4 factors that affecting the rate of reaction. Remember to memorize all the factors, which is size of solid reactant, concentration of reactant, temperature, and the use of catalyst. And you can use acronym CSTP. I repeat again, you can use acronym CSTP to help you to remember the factors. And also don't forget to relate the factor with the collision theory. Hope you understand the lesson for today and see you guys in the next lesson. Bye!